Good morning. Welcome. We're going to work on question number 5 from the 2019 BC practice exam. For this question, we cannot use a calculator. All right, so number 5, the graph of the curve C is given by this function, which is shown in the figure above. First, we have to show that dy dx is equal to this. All right, we're going to be doing some implicit differentiation here. This question is all about knowing how to take derivatives because they're already telling us what the answer is. We just have to show it. And your work has to be correct because if a step is wrong, then even if you write this answer, you're not going to get the points. So, implicit differentiation. And that means that if you're taking a derivative of a letter that is not x, think of it as a mystery function and you have to apply the chain rule because we are taking the derivative with respect to x. So, quick little recap. If you're taking the derivative with respect to x and you're deriving x, well, that's just going to be 1. But if you're taking the derivative of anything else, well, then it's going to be dy dx. You could write y prime for short. And that is the same thing for any other letter, right? Every single letter is going to be considered a function because it's not x. It's just a function of x. So let's go ahead and find our derivative. 4x squared plus 3y squared plus 6y is equal to 9. My derivative with respect to x is 8x plus, right here is where we have to use the chain rule. It's going to be 6y times dy dx. The derivative of 6y is just 6y prime, and the derivative of 9 is 0. Since we're going to be solving for y prime, I'm going to go ahead and subtract the 8x from both sides. But I'm also going to factor out a y prime from the remaining terms. So y prime, 6y plus 6 equals negative 8x. Then I can go ahead and divide by 6y plus 6. To show my work, I'm going to show you that I'm going to factor out a 6. The denominator is going to be 6 times y plus 1. That is going to allow me to reduce the fraction by 2. So my derivative becomes negative 4x divided by 3y plus 1. And that's the derivative that we needed to show. That's 2 points. So you get 1 point by doing implicit differentiation, and you get 1 point for arriving to the correct solution. Okay. Use the information in part A and find the second derivative. Okay. So we said that the derivative is negative 4x divided by 3y plus 1. All right. Again, just the derivative with respect to x. So the first thing we got to do is the chain rule. So the second derivative is going to be the bottom. And you know what? Put it in parentheses or brackets. It's the bottom times the derivative of the top minus the top times the derivative of the bottom. The derivative of the bottom is just going to be 3y prime. All over the bottom squared. All right. Let's clean this up right here. Negative 12 y plus 1 plus 12x y prime. But instead of writing y prime, we're going to go ahead and replace it for what it should be. Y prime, we know it's negative 4x divided by 3y plus 1. Now, in a question like this, they don't really tell us how much to simplify by. So, I mean, I'm for sure going to multiply these two. Let's see. Let's just take it one step at a time. That's going to equal to negative 12 y plus 1 minus 48x squared divided by 3. Oh, you know what? Let's reduce. This 12 can be divided by 3. That's going to give us 4. And then 4 times 4 is 16. So 16x squared divided by y plus 1. All over the bottom squared. And actually, if I look at my answer key, that's as far as they took it. You could take it further, because you never really know when to stop. And again, this is okay already. This would get you the full points, but I'm going to just continue simplifying it just in case to show you guys. I'm going to have to get a common denominator right here, which means I have to multiply by y plus 1. Negative 12 y plus 1 squared over y plus 1 minus 16x squared over y plus 1 divided by 3 y plus 1 squared. That's going to allow me to put the fractions together, which is negative 12 y plus 1 squared minus 16x squared over y plus 1. In the remaining denominator, I'm just going to go ahead and multiply by the reciprocal. And watch this. That's going to be 9 y plus 1 squared. Hopefully you caught that because I just squared the denominator. And the reason that I did that is because now I can actually combine the fractions even further and say that my final answer is negative 12 y plus 1 squared minus 16x squared divided by 9 y plus 1 cubed. Now again, we didn't have to go this far into the question to get the point. The point was awarded in the step where I boxed in my answer. But that is your second derivative. If you're in doubt, keep in mind that you have a time limit in the AP test. So just maybe leave it like that. Then if you have time, come back to it and simplify more. But don't waste valuable time trying to simplify something for 1 point. Right? Leave it like that, and hopefully we get awarded the point. Part B. Or part C. In polar coordinates, we're given an equation for the radius r. Find the RD theta. As theta increases, on what intervals is the distance between the origin and the point increasing? So the key word right here is increasing, right? That's going to tell me automatically that my steps are going to be find my derivative, set it equal to 0, get some critical points, and do a number line. And they already explicitly told me that I should find a derivative anyways with respect to theta. Well, first, since I'm taking a derivative, I got to use the quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom. And the derivative is going to be cosine of theta all over the bottom square. Okay. The first part of the quotient rule, that one goes away since we're multiplying by a 0, which means my derivative becomes negative 3 cosine of theta over 2 plus sine of theta squared. That's your derivative. That gets you 1 point. We want to find some intervals where the function is increasing. So like I told you, we're going to go ahead and set it equal to 0. Now, either way you see it here, the denominator does not play a role. We just want the numerator to be equal to 0. But also, the denominator is being squared, so it's going to be positive no matter what. So again, the denominator does not affect this in any way. So really, you should be just focused on this. Divide by -3. Take the inverse of cosine. And hopefully you know your unit circle pretty well, because cosine inverse of 0 happens at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on. But we are restricted, right? We're only going from 0 to 2 pi. So those are my only 2 critical points. Third, to find me some increase in intervals, I'm going to go ahead and set up my number line. My first critical point is pi over 2. Oh, and remember, we're only going from 0 to 2 pi. So I'll get some more space right here. Pi over 2, 3 pi over 2. And we're supposed to plug this into the derivative, because this is going to tell me if the derivative is positive or negative. So why don't I pick something I can evaluate pretty easily, such as pi over 3. dr d theta equals -3 cosine of pi over 3. I'm not even going to write the denominator because I know it's going to be positive. So the question is, what's cosine of pi over 3? Is it positive? Is it negative? Well, it's positive. A negative times a positive divided by a positive is a negative. And in case you're wondering, the actual value of cosine of pi over 3, that's 1/2. Okay. So now let's go with pi. dr d theta equals -3 times cosine of pi. Cosine of pi is -1. And the denominator, no matter what, it's going to be positive. So that's positive. And then finally, let's plug in, I don't know, 11 pi over 6. -3 times cosine of 11 pi over 6. Cosine of 11 pi over 6 is positive because if you think about the unit circle, cosine represents the x coordinates. And on the fourth quadrant, all your x coordinates are positive since we're moving to the right. So positive, and the y coordinate is negative. So that's why I get a positive. Oh man, it's freezing. Give me a second. Positive. So that becomes negative over a positive, which is negative. So back to the question. On what intervals is the distance between the origin and the point increasing? Distance between the point and the origin is increasing on the interval from pi over 2 all the way to 3 pi over 2, because dr d theta is positive. That's it. When you put your interval, make sure you put it in parentheses and not in brackets. The endpoints are not included. The endpoints are critical points. The endpoints make your derivative 0, not positive. You could lose the point if you put a bracket. Okay. Part D. Let S be the region in the curve C as defined in part C, but outside of the curve R equals 2. You know what? Let's go back to the original picture and let's draw it. Let's draw the curve R equals 2. That's just going to be a circle with radius 2. So 2, 2, 2, 2. And once again, the question says S is the region inside C, but outside of the circle with radius 2. So that's going to be this. That's going to be this area. Inside of C, but outside the circle. Notice how we have 2 points of intersection, right? Those are going to be important. Right, but do not evaluate an integral to find the area of S. Well, first of all, if we're going to find the area, we first have to find the points of intersection. And think ahead, right? Technically, we are working with a circle, and the points were in the third quadrant and the fourth quadrant. So keep that in mind as you find your angles. So one of the curves is 2. The other curve is 3, 2 plus sine of theta. Solve for theta. Okay, we're going to multiply by the denominator on both sides. Then we're going to go ahead and divide by 2. Again, this is not the only way you could do this. You could take different steps. Then we're going to subtract 2. But 2 is equivalent to 4 divided by 2. Then you're going to take the sine inverse. And the sine inverse of this side is going to be negative 1/2. So then the question is, when does sine give you negative 1/2? That's going to be at 7 pi over 6 and 11 pi over 6. And that's good because those points, if you think about the unit circle, those points are here and here. And that looks pretty similar to where the graphs intersect. So that's a good indication that we got the correct critical points. 2. Now we have to find the area. And finding the area of polar curves is really similar to finding the area of regular functions. The area is going to be the integral from alpha to beta, or you can think of it from A to B. The formula, though, it's 1/2 r squared minus 1/2 r squared d theta. When you have 2 polar curves intersecting, you have to do this. It's kind of like doing top minus bottom, where this one is the bigger curve or the outer curve, and this one is the inner function. And when I say outer and inner, I mean the furthest one away and the closest one. So here's what my integral is going to be. Factor out the 1/2. Take your critical points and set up your integral from 7 pi over 6 to 11 pi over 6. Now the big radius is, here, let me go back to the picture. The furthest distance here from the angle of rotation, it's the function c. And the smaller radius is r equals 2. So the function c is 3 over 2 plus sine of theta squared minus 2 squared d theta, and that gives you your answer. Okay. Thank you very much. I'll see you guys next time for question 6.